Okay, gang. Before I do the second derivative test on this, you want to work on the domain. Alright, so there's two problems here. You have a fraction and you cannot divide by 0, and you also have an ln. So I'm going to say this in two ways for starters. The first thing I'm going to say is for the ln, x has to be greater than or equal to 0. That is the domain of an ln. Sorry, not equal to 0, just greater than 0. That is the domain of an ln. But also this is in a fraction, so you can't divide by 0, and you'll be dividing by 0 if x is 1. Right? Because the ln of 1 is 0. So you'd have 1 over 0. Let me just draw this for you as well. So you can't use 0 because that's a domain restriction for ln. And you can't use 1 because ln of 1 is 0. You're dividing by 0. But you can use things between 0 and 1 and numbers greater than 1. So that's the domain of this. And I'm pointing that out because you can only do the second derivative test on values where the function exists. If the function doesn't exist at certain values, you shouldn't be testing them. Okay, I did the derivative calculator and then I just sort of rewrote it because sometimes people think there's like a parenthesis here and there's not. There's only an x in the ln, the minus 1 is in front. Same thing here, just want to make sure you saw this correctly. This is 2 is not in the ln. You have to have parentheses to include anything but the first thing in the ln. The default is it only includes the thing it's sitting next to and nothing else. Okay, so just watch that you don't, make sure you interpret what you're looking at correctly. Okay, so I need, for the second derivative test, you need the critical number. So the critical number occurs where the derivative is equal to 0 or undefined. So I'm going to first see if I can set this equal to 0, the numerator. Right, so you have to sort of check, can the numerator equal to 0, can the denominator equal 0, right? So negative 1 plus ln of x equals to 0, or ln of x equals to 1. This is base e, so e to the 1 equals to x, or x equals to e. Alright, so that's your first critical number. And this function will equal to 0 when x is 1, but we're not allowed to use that because it's a domain restriction, so therefore it's not a critical number. You cannot be both a domain restriction and a critical number. So that's the only critical number we have. So if you remember, how you do the second derivative test is you find the critical number and then you plug the critical number into the second derivative. So now I'm going to plug it into the second derivative. Here I go. Okay, so ln of e is 1. You guys learned that in pre-calc. So this is 2 minus 1 over e times ln of e again is 1 cubed. So I have 1 over e when I do all the simplifying. E again is something like 2.718, blah, 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 but this is positive and this is positive. So all we really care about is that this is positive. This is greater than 0, right? That's what we care about. This is positive. So if it's greater than 0, it's concave up. And since it's concave up, that means that you have a relative min. So you have a relative min at e, that's the x value. You could then go back and figure out what the full value is if you plug e into the original function. So if I do that, just so we actually have the relative min, so x is e, so I'll put an e here, e over ln of e. Again, ln of e is 1, so it's e over 1 or e. So the relative min is occurring at EE, which is about, 2.718, comma 2.718. So that is the answer. That is the, when you're doing the second derivative test, you have to show that you're plugging the critical number into the second derivative. I'm looking for that. And then you have to do, if it's greater than 0, it's a minimum. If it's less than 0, it's a maximum. And then if it's equal to 0, that test fails, and you have to go back to the first derivative test. All right, gang, that's it on this one. Hope that helped. Bye-bye.